A class of 7th graders wanted to find the proportion of M&Ms that are red. Each 7th grader took a random sample of 20 M&Ms from a very large container of M&Ms. The following is the proportion of red M&Ms that each student found. Part A asks us to create a dot plot from their proportions. Our smallest value in the table is 0, and the largest value is 0.3. Now what we need to do is create a dot for each point or each decimal in the table. Part B says describe the shape. So if we were to describe the shape, we could say that most of the data is on the left, and then it trails off on the right side. The long tail helps us identify which side is skewed. So since our long tail is on the right, we can say in part B that it is skewed right. And we can also say that there is a cluster or a big group around point 1. C says to describe the variability, meaning where it starts and where it ends. So you're going to say something about how the spread is from 0 to 0.3 in part C. In number 2, it says a group of 7th graders wanted to estimate the proportion of middle school students who suffer from allergies. The members of one group of 7th graders took a random sample of size 10, and the other group used sample size 40. Below there are 2 dot plots, one that's going to represent 40 for the sample size and one that will represent 10. Which dot plot is based on a random sample of 40, and how can you tell? The more information we have, or the more data we use, the closer our values get to the proportion for the population. So for this, if we have a sample of 40, we would expect our dots to be closer together. That means dot plot A uses the sample size 40. Because the dots are closer together and it has a smaller variability. Number 3. The nurse in your school district would like to study the proportion of middle school students who usually get at least 8 hours of sleep on school nights. Suppose each student in your class plans on taking a random sample of 20 middle school students from your district, and each calculates a sample proportion of students who said they usually get at least 8 hours of sleep on school nights. A. Do you expect everyone in your class to get the same value for their proportions? Think about the lessons we did in class. When we did a sample of cubes out of a bag, did everyone get the same proportion? No. We should get similar results, but with random samples, we will experience some variability. B. Suppose each student in class increased the sample from 20 to 40. Describe how you could reduce the sampling variability. The more data we use, the closer they get to that population proportion. So using more data the less sampling variability we will see. If we went from 40 to 100, we would see even less sampling variability. The more pieces of data we use to collect each sample proportion, the closer our points will be, which reduces the sampling variability.